This video is going to talk about putting equations of lines in slope-intercept form. So I have on the screen the formula for slope-intercept form of a line. If the equation of the line is solved for y, so notice that my equation has two variables, two letters in it, y and x, and so if y is by itself on one side of the equation, then we say it's in slope-intercept form. The number in front of the x, we'll call that m, this is going to be a number or a constant, is always going to be the slope of the line. And the constant, the number without an x, is always going to be the y-intercept of the line. So let's see how this works with a few examples. Find the slope and the y-intercept of each line. I have the equation y equals x minus 3. This equation is already in slope-intercept form because y is by itself on one side of the equation. So to get the slope, I'm going to identify the number in front of the x. The x doesn't have a number in front of it. That means it's only one x. It's kind of like there's an imaginary 1 there, and that is my slope. The slope of this line is 1. The constant, the minus 3, is my y-intercept. So the y-intercept would be located at the point 0, negative 3. Here's another one. Find the slope in the y-intercept, and we have the line 2x minus 5y equals 10. This equation is not in slope-intercept form yet because we haven't solved it for y. So the first step is to get y by itself. To do that, I have to subtract 2x from both sides. So again, I'm trying to isolate or solve for y. So I need to move the 2x to the other side, and that gives me negative 5y equals negative 2x plus 10. Now to finish, to get y by itself, I'm going to get rid of that negative 5, and I'm going to divide all of the terms by minus 5. So now I'm left with y equals negative 2 over negative 5. A negative divided by a negative is a positive. So that's positive 2/5 x. And then 10 divided by negative 5 is negative 2. Now this equation is in slope-intercept form. And so the number in front of the x is the slope, the m. And the constant, the number without the x, the negative 2, is the b, or the y-intercept. So the slope of this line is 2/5. And my y-intercept is located at the point 0, negative 2. We can use slope-intercept form to actually create graphs of lines without making a table of values. For example, if I want to graph the line y equals 1/2 x plus 3, this line is already in slope-intercept form. The slope is the number in front of the x, 1/2 in this case, and the y-intercept is the constant, or b. So my y-intercept is located at 3. That means I know that this graph, or this line, crosses the y-axis at 3. The point 0, 3 has to be on the graph of this line. Because my slope is 1 over 2, slope is rise over run, that means I can go up 1 and over 2 units to get to my next point. So I'm going to go up 1 and over 2, and there's another point on the line. I can repeat that process, go up 1, over 2, to get yet another point. And I can continue that process, up 1, rises 1, over 2, to get as many points as I want in order to create that nice straight line of that graph. And there's the graph of y equals 1/2 x plus 3. Here's another one, same instructions. Let's use the slope and the y-intercept to graph. The first thing I notice is that this equation is not in slope-intercept form. To get it in slope-intercept form, we have to solve for y, and so that means we have to minus the 3x. Move that 3x to the other side. Now I have the equation y equals negative 3x plus 4. The slope is the number in front of the x, so slope is negative 3. The y-intercept is 4, the constant. So to create my graph, I'm going to start with that y-intercept of 4. So I'm going to go ahead and plot a point at y equals 4 on that y-axis. That's my y-intercept. And then because the slope is -3, we can write that as -3/1. So my rise is -3, down 3, and my run is +1. So from that y-intercept, I'm going to go down 1, 2, 3, and over 1. And there's a point on that graph. I can do that again, down 1, 2, 3, over 1. And there's another point on that graph. If we connect the dots, there's a nice graph of our line, y equals -3x plus 4. Now, I chose to write the -3 as -3 over +1, but I could have written it as +3 over -1. That's the same thing as -3. This means my rise would be +3 and my run would be -1, or to the left 1. And notice that gives us the exact same line. If I just pick a place to start, if you go up 1, 2, 3, and to the left 1, you're still on that same line. So I could have gone up 3, to the left 1, and gotten the exact same graph. Now, we can use the concept of slope-intercept form to start to write equations of lines if we're given information about those lines. So, for example, this problem says, write the equation of a line with m equals -3, so slope is -3, that passes through the point 0, 2. My y-intercept is 2. When x is 0, the number that goes with x equals 0 is always your y-intercept. So we actually know both the m and the b, and we can just plug that directly into our slope-intercept form. Y always equals mx plus b. If the m is -3 and the b is 2, that turns into y equals -3x plus 2. That would be the equation with a slope of -3 and a y-intercept of 2. Here's another one. Write the equation of a line that passes through the points 1, 5 and 0, -3. Now this time they're not telling us what the slope is. However, we have learned in the past how we can actually compute that slope. And they are giving us the y-intercept. The y-intercept always has an x value of 0. So when I look at these 2 points, the one that has an x value of 0 is my y-intercept. Again, that's important. The y-intercept is not any point on the line. It's a very special point. It's the point that has an x value of 0. So when x is 0, y is -3, that's my y-intercept. So we know what the b is, but we don't know what the slope is. However, in the previous video, we learned that we can compute slope by taking change in y divided by change in x. So I'll let my first point, 1, 5, be the x1, y1, and the second point, 0, -3, be x2, y2, and then I can just plug those numbers into my formula. y2 minus y1, -3 minus 5 is -8, and x2 minus x1, 0 minus 1 is -1. -8 divided by -1 is +8, and that's my slope. Now that I know the slope and the y-intercept, I can just plug those numbers into my formula. Y equals m, which is 8, x minus 3. And there's the equation of this line. Finally, let's see if we can write the equation of a line if we're just given its graph. We can run through the same kind of thought process. This time we're going to have to work with the picture instead of numbers. I'll be able to put this equation in slope-intercept form if I can find both the slope and the y-intercept. And looking at the picture that's given, I immediately can tell that the y-intercept is at 4. This graph crosses the y-axis at 4. So that's the b. To find slope, I can use the rise over run definition. So to get from 0, 4 to 6, 0, I have to go down 4 units and over 6. So the rise is -4 and the run is +6. That reduces down to -2/3. So if my slope is -2/3 and my y-intercept is 4, I can just plug those in to get the equation. Now I do want to point out we can also use that same slope formula to get the slope if you don't like just visually doing rise over run. The y-intercept is at the point 0, 4. This x-intercept is located at the point 6, 0. So we could take y2 minus y1, 0 minus 4, divided by x2 minus x1, 6 minus 0, and that gives me the exact same slope, -4 over 6, which reduces to -2/3. So plugging that into my formula, y equals mx plus b, my equation turns into y equals -2/3 x plus 4. That was my last example. We'll continue with this topic in the next video.